Okay, cool. Let's just get started. So this is the first session of CUR Mini 2021, and session one is about getting started. First, I think it would be good if we make an introduction for ourselves. So my name's Jerry. I'm a third-year engineer, and I'm doing the info electrical module. And yeah, so nice to meet you all here. Xinjian, would you like to introduce yourself?
Yeah, hello. My name is Xinjian. I'm a second-year physicist, so I'm not an engineer, but I did the CuR minibots last year, so you can see that it's quite beginner friendly and inclusive.
And Jay?
Yep. Hi, everyone. I am Jay. You might remember me from Intro Day. I'm the president of CuR, and I'll be starting off this presentation with a bit more information, a bit more background.
So me and Xinjian are the project lead of minibots, and we'll be basically conducting all the sessions from now on. Yeah, first of all, perhaps Jay, you want to give us a bit more info on why we have minibots?
Yes. So our mission at CuR is very simple. We want to make robotics more accessible for everyone. And this includes beginners, people who have no experience with robotics. Now, this year is the 4th year of us running minibots. And each year we try to improve the program so that we can teach you more and you will learn more skills. So yeah, CuR, Cambridge University Robotics Society, we can be found on all like Twitter, Facebook. You can also email us. We do have a website, and we also have partners and advisors like Autodesk and DeepMind. These people are very useful if you need a little bit more advice. If you are trying to start your own project or something, we can get you hooked up and, you know, get a conversation starting. So what can you expect after completing minibots? By the time you finish minibots, you would have learned how to assemble your own sort of small rover robots. You would know a bit of electronics of how to get power to all the systems, how to prevent short circuits, and how to program the Arduino in this case, so that you can instruct the robot to do things. Now, these are very relevant skills in robotics, and they can be applied to many different areas in robotics. So this program is really a good starting point in your robotics journey. After this minibots, after 8 weeks, you would have gained enough skills to move on to another project that CuR offers, which may be of higher difficulty. I believe many of you would find a confidence to take part in these and sort of build that skill continuously. If you like the format of minibots, we do have a few other opportunities. For example, next year around March, we are co-hosting a competition with Southampton University called Unibots. The structure will be very similar to minibots, and for those engineers, it will be quite similar to IDP. So more details on that will come on a later date. But that's one big competition that you can look forward to. There are about 14 other universities, robotic societies taking part. Another one, more sort of UK-wide competition, is called Pi Wars. Now that will be, instead of using the Arduino, we will upgrade to the Raspberry Pi. And there's a lot of interesting challenges in the Pi Wars. So that's like another step up from minibots. And I think you will transition quite well into these two competitions.
Cool. Thank you very much. So basically, minibots if you haven't had any prior experience with robotics before, minibots will be your first step to build up your confidence and skills. So so hopefully you can enjoy it. So I feel like it would be helpful to give you a bit of knowledge of what happened for the past CuR minis. So that was the CuR Mini 2018. That was before I entered uni, so I wasn't really sure about the details, but it's the task is mainly like a line following and object picking robot that looks like that. For the minibots 2019, we built sumo bots that will compete with like sumo bots built by the other teams, and to try to push the robot, your opponent robot, off a like 1x1 squared arena. And for last year's minibot 2020, we built a robot that could roam in a maze and pick up a ping pong ball on a stand. Yeah, and for this year's challenge, you will have to be building and testing your robot in teams up to 6 members. The minibot you're going to build is fully autonomous, and you have to do tasks such as assembling, wiring, coding, and testing. And it has to be done in 8 weeks before the term ends. There will be an internal competition at the end of the term. So hopefully it will be on the last session, Wednesday. So it's basically the last day of term. And in the competition, the robots will get deployed in the arena to compete with each other. The task is to collect as many target objects in the amount of time given as possible. A bit more details on the competition. It's called 7-block pickup. The arena is loosely bounded by tapes only. So if your robot roams outside the arena, nothing will stop it. And there will be 7 blocks placed randomly on the in the arena, but rotational symmetrically. And the robot will each start from one end and try to grab the token and bring it back to the initial position in 3 minutes. More details can be found in the rule book on our wiki, which I will introduce later. So here is the robot. On the left is a demo bot that I built, which will be very identical to the one that you have in the end. And this is a CAD model of the design of the minibot. So this is, excuse me, would you mind turning your mic off? I'm not sure who this is, but it has the name SR. Thank you, because it was echoing in the background. And here there's a demo of how the bot can work on doing a line follower. The way it moves is a bit crap because the table is not really suitable for this kind of wheels, and there was a bit of flaw with the design, but basically it demonstrates how one of the tasks, which would be following the line to pick up blocks along the line, would be like for this robot. Okay, so now I would like to talk about the session schedule. We are now at session 1, and it's the introduction session. So the next 6 sessions will have lecture-like sessions where we would introduce different concepts relevant to the minibot. For the next session, we'll be talking about the physical design and manufacture of a minibot. Like what means are there for us to rapid prototype such a minibot? How do you laser cut the chassis? How would you 3D print and design? How would you design and 3D print the different parts? How would you choose the electronic components based on the requirement of the task? On session 3, we'll talk a bit more about Arduino, microcontrollers, and details about the minibot kit that you will receive if you are like joining this project. For session 4, we'll discuss how to use actuators such as motors and servos and the different sensors to control how the actuators would work. For session 5, we'll be talking about I2C devices, which is a device that uses protocol on Arduino. Session 6 and 7 is to be decided yet, but it will probably be more extended parts of robot, not necessarily like limited to just minibots. And here is what you can expect to learn. You learn how to use a laser cut. You will learn how to laser cut, how to use 3D printing machine, and how to design with CAD. For electrical, you will learn how to do circuit design, how to use microcontrollers, how to use common electrical components, and how to prototype on breadboard. For software, you will be learning how to program with Arduino, to use the Arduino IDE, and learn to debug. The general engineering skills you will be learning is to solve a problem with constraints. So for example, all the components we give you are those like more of those cheap ones, and you are trying to accomplish a task with limits on them as they are cheap and they just don't work as well as the expensive ones. You will learn to debug a system until all the desired functionality are reached. And that means you are able to enter your robot into the competition. The structure of the project would be, first of all, we have weekly meetings on Zoom, and it will be focused on like an aspect of the minibot. It's a bit like lectures you get in Cambridge. And as you can see in the previous schedule, we've the topics of what will be discussed in each session. And your team should arrange sessions suitable for everyone to work on the minibot in your own time. And the recommended time is 2 hours per week. We would have 1 to 2 meetings with team supervisors. So they would all consist of members of the CuR committee after week 4. And the supervisors will make sure that you're on track, and they will help you whenever you get stuck. They can be in person or online, like whatever you prefer. And we have the competition on the final session, and the winning team will get an edible prize. So here are some important timelines, some deadlines. For the sign-up deadline, it's going to be on the 15th of October, midnight. So that's on Friday. And we'll finalize the team on Sunday, 17th of October. We'll hand out the kit between session 2 and 3. We'll usually just hand it out to the team lead of the, wherever the team lead is. And the supervision sessions occur between session 4 and 8. And the competition will happen on 1st of December, but it is subject to change. And we'll be having Unibots in Lent term. That's due to happen. And Jay has already given you a bit knowledge about Unibots. So here are some of the resources available for this project. First of all, we have the CuR website, where you can find info about who to contact, info about the projects, and also like other info relevant to the project. We have the wiki, where we have the CAD model and the rule book for this for minibot. And there is this Dyson Center that I would like to introduce, because I believe we have not just engineering students, and Dyson Center is really helpful if you are trying to make a robot. It's got all the tools that we need to manufacture this minibot. And that's why for those outside who are not doing engineering, you should definitely have a look at the Dyson Center website to see how you can get access and what kind of amazing stuff you can do in the Dyson Center. Yeah, at this moment, I think I should just pause the presentation for a second and go a bit more details about the about website and wiki. So just looking at the chat to see if there's any question. Cool. So if you go to the homepage, it will be like that, and you go to the project and events and click on CuR Mini 2021. This is some general info about the competition, and there's the sign-up sheet for the project. Click on the CuR Mini wiki. So later on in the term, this is where you will get most of the info about the competition and about the project itself. For all those sessions like this, the slides and video will be uploaded here shortly after the session ends, and you can find the rulebook here, and you can find the CAD file here. So there's both the SolidWorks assembly file and the step file. So if you are doing engineering, you should already have SolidWorks SolidWorks installed on your computer. If you are not, you could either try Fusion 360, which I believe is a free CAD software, and use the step file. I use the step file to access the CAD model, or you could try getting access from the engineering department. I think that is possible, though I am not really sure about the details. I'll probably have a look into that. And to demonstrate how you would use the CAD file, if you download this SolidWorks assembly and you have SolidWorks installed, it should look like that. And you can have a play around it if you want to see any individual. Say if you want to see some stuff you can do here is, oops, why am I clicking the dimensions? You can make the hot bit, you can hide it and see what we've got here. So for the CAD, there is no wiring and those smaller components such as the motor driver. It's mainly the motors and the gripper at the front and the Arduino. This bit is supposed to represent the battery, but as we have been deciding on whether to use a normal AA batteries or LiPo batteries, so we just use a dummy cuboid here for the moment. And yeah, and also there is a bit of bug in this design. If you want to play around it, it would be fun to see if you can spot the bug. The problem with it is that when I discovered the bug, all the chassis has already been manufactured. So I manufactured it in Dyson Center. So I'm not sure if this bug will be fixed when I hand the kit out to you. But if no one finds out about the bug, it will probably just be there as a feature of minibots 2021. Yeah, I think that's what I want to show for this session. Let's resume the presentation. So the selection process exists because last year we had quite a lot of people interested in the project, and we will be giving out 8 kits. And so in case there are more participants than the kit can accommodate, the selection will be based on whether you have we got that sign-up form, and there are questions that will tell us about those aspects. So whether if you have a team already, whether you want to be a team lead or team member, whether you attended this session, and aspects that show your interest in general. the purpose of the selection process is that we want, if we are handing out the kits to you, we hope that you would carry on with this project and produce a working minibot in the end that will that enters the competition. So we are just trying to see if you would stick to this project, basically. But and don't be worried if you don't have any previous experience, because this is meant to be a freshest project for those who have no previous experience. Sorry. So I think at this stage we can move on to the action points. So for those who haven't signed up, who haven't filled in the sign up form yet, here's the QR code to it. You can also find it in our website. After Sunday, we'll send out emails to those accepted to this project, and we'll send you a link to join the Slack channel. And it would be nice if you can have an idea of the challenge by reading the rules on Wiki. And finally, this is not like compulsory. It would be kind of fun to see if anyone can spot the bug in the minibot chassis design. The designs, the cat is on the wiki. And also, this is a screenshot from our term card. There are some other projects to look out for if you think minibots is too easy for you. Also, you can consider them as choices, as projects you might want to enter after finishing minibots. So I think we are at the end of our presentation, and I'll be happy to take in questions right now.